Here's a fact that quietly rearranges everything you thought you knew about yourself. Every single person alive today, no matter their color, descends from ancestors in Africa who had dark, deeply pigmented skin. Your family tree, mine, everyone's, all of it climbs back to the same sun-drenched beginning. So, if we all started in the same place, wearing the same shade, then how on earth did human beings end up painted in every tone, from deepest brown to palest ivory? And why did that change happen the moment our ancestors began to wander north? Let's go back to the beginning. Early humans in Equatorial Africa lived under some of the most intense, ultraviolet radiation on the planet. The sun there is not gentle. And UV light, it turns out, is a double-edged thing. Your body actually needs a little of it, because sunlight on skin kickstarts the production of vitamin D, which you need for strong bones, a working immune system, and healthy reproduction. But too much UV is dangerous in a very specific way. It tears apart a fragile B vitamin in your blood called folate. And folate is the quiet hero of building a healthy baby. When folate runs low during pregnancy, the result can be devastating birth defects of the spine and brain, conditions like spina bifida. So, under that relentless equatorial sun, the ancestors who survived and raised healthy children were the ones whose skin could shield that precious folate. Enter melanin, the pigment that colors our skin. Melanin is, quite literally, a built-in sunscreen. Rich, dark, eumelanin-heavy skin absorbs and scatters incoming UV, protecting the folate below while still letting just enough light through to make the vitamin D you need. In a place that bright, dark skin is not incidental, it is a life-saving adaptation, honed by hundreds of thousands of years of natural selection. This is the heart of a theory developed by the anthropologist Nina Jablonski and her colleague George Chaplin around the year 2000, and it is one of the most elegant ideas in all of human biology. Here's the beautiful part. Jablonski and Chaplin took NASA satellite maps of ultraviolet levels across the whole planet and compared them to the skin tones of native populations living in each region before the age of global travel. And the match was stunning. Skin reflectance lined up almost perfectly with latitude and UV exposure. The closer people lived to the equator, the darker their skin. The farther toward the poles, the lighter. Skin color, it turns out, is essentially a map of sunlight painted onto the human body. Because think about what happens when our ancestors start walking north. As people migrated out of Africa and into Europe and Northern Asia, the sun grew weaker and slanted. Winters stretched long and dim, and now that same dark skin, so perfect near the equator, becomes a problem. There simply is not enough UV reaching the ground to punch through all that protective melanin and make adequate vitamin D. And a body starved of vitamin D is a body with weaker bones, a shakier immune system, and greater risk in childbirth. So the pressure reverses. In the north, the advantage flips to lighter skin, skin that lets scarce sunlight in, so the body can still manufacture the vitamin D it desperately needs. This is what scientists call a balancing act, a compromise written into your skin. Near the equator, evolution turns the melanin up to guard your folate. Near the poles, it turns the melanin down to rescue your vitamin D. And in the great middle latitudes, you get medium tones and the ability to tan, skin that adjusts with the seasons. Your color is the settlement your ancestors' bodies reached between two competing demands of the sun. Now, this is where the story gets genuinely surprising, because lighter skin is not some ancient, deep feature of northern peoples. It is shockingly recent. Take a gene with the unglamorous name SLC24A5. A single tiny change in this one gene accounts for a large share of the difference in pigmentation between European and African populations, somewhere between a quarter and a third of it. That is an enormous effect from one tweak spot in your DNA. And this light skin variant swept through European populations under powerful natural selection. Remarkably, the very same variant is shared by people across Europe and South Asia, inherited from a common ancestral source. Evolution found a lever and pulled it again and again. And here's the twist that stops people in their tracks. Lighter skin did not evolve just once. It evolved independently, more than once, in different parts of the world, as separate populations wandered into low sunlight lands and faced the same vitamin D problem. Nature, running the same experiment on different continents, kept arriving at similar answers. That same SLC24A5 variant even turns up in the Khoisan people of southern Africa, carried back into Africa by migration only around 2,000 years ago, and then favored by selection there too. Skin color is not a fixed badge of any group. It is a dial that evolution keeps turning wherever the sunlight changes. But if you want the single fact that truly detonates old assumptions, it is this. In 1903, in a cave in Cheddar Gorge in southwest England, workers uncovered a nearly complete human skeleton, roughly 10,000 years old, the oldest such skeleton ever found in Britain. For over a century, people pictured him as pale. Then, in 2018, scientists at the Natural History Museum and University College London drilled a tiny hole into his skull, pulled DNA from the dense bone of his inner ear, and sequenced his entire genome. And what they found rewrote the picture completely. Cheddar Man, a Briton from 10,000 years ago, had dark skin, dark, curly hair, and striking blue eyes. Sit with that combination for a moment. Dark skin and blue eyes together, in an ancient European. It felt almost impossible, and yet there it was in his genes. And he was no fluke. His profile matches other hunter-gatherer remains from the same era, found in Spain, Hungary, and Luxembourg. Scientists had long assumed that humans turned pale almost as soon as they entered Europe some 45,000 years ago. Cheddar Man says otherwise. The pale skin we think of as typically European is a newcomer, arriving only in the last several thousand years. For most of the time, modern humans have lived in Europe. They were dark-skinned. If you love this kind of stuff, subscribe, because I go deep on a new question about being human every single week. And this brings us to the finding that ties the whole story together with a bow. In 2017, the geneticist Sarah Tishkoff and her team measured skin tone and combed the DNA of more than 2,000 people across Africa. And they discovered that Africa itself holds an astonishing range of skin colors, from among the darkest on Earth to shades as light as some people in Asia, all on one continent. More than that, the genetic variants that control skin color turned out to be ancient and shared. Many of the very genes that produce lighter skin did not appear in Europe at all. They are old African variants, some of them older than our species itself, carried quietly in humanity's shared inheritance. The same handful of genetic switches, shuffled and dialed differently, produces every shade of every person who has ever lived. So step back and look at what your skin color actually is. It is not a marker of where you belong, or who your people are, or anything about your mind or your worth. It is a thin, living layer of sunscreen, tuned by your ancestors' bodies to the exact angle of sunlight where they happen to raise their children. It is one of the clearest, most beautiful examples of natural selection ever found acting on the human body, and it is skin deep in the most literal sense. Underneath, we are one species, astonishingly, almost boringly alike. All of us the great-great-grandchildren of dark-skinned Africans who looked up at the same sun. The next time you notice the color of a stranger's hand, remember what you are really seeing. Not a border, not a category. Just a message from the sky, written over countless generations, recording how much sunlight fell on one branch of a single human family as it spread across the world. We are not many kinds of people. We are one kind, wearing the light of the places we come from. And that, when you truly understand it, might be the most quietly wonderful thing about being human at all.